Hey guys, how you all are doing? I hope you all will be doing fine. So welcome back to Rejoin Tech. This is going to be the second video in Leetcode series in which I'll be telling you no doubt about the first question on Leetcode. You guessed it right, it's about two-sum array. So I'll be going through all the way from naive, brute force, intermediate to efficient one. And it's really useful to learn the brute force so that you build up the concept gradually and not to directly dive into an efficient solution. So stay with me till the end of this problem because you will be learning this question and won't be forgetting it lifelong. So let's quickly begin this video. Before getting into it, if you haven't subscribed to Rejoin Tech, kindly do it because you will get a lot of things to learn and moreover it motivates me a lot. So let's begin the problem. So this is the question I was talking about, two-sum, that is number one problem of Leetcode. So basically the problem statement is as follows: given an array of integer nums and an integer target, return indices of two numbers such that they add up to the target. And basically you assume that there will be exactly one solution, there might not exist two different solutions. These are the constants that are usual ones. Minus 10 to the power 9 will be the constant and it goes up to 10 to the power 9. So basically we need not worry for constants when we are talking about brute force approach. So let us first of all understand what is our problem here. So basically you are given an array that is A and a target that is a number as well. So what you need to do here is you need to find two such indices that adds up to the target. So there will be two types of this problem. So the first one which we'll be talking about is you just need to tell whether such number exists or not. So here it is. So first of all we'll go through all the numbers in array. Let's see whether sum 12 exists or not. So 2 plus 4, that is 6, doesn't matches. 4 plus 8, that is 12, it is correct. So we will be going with yes. This is the first variety of problem in which we just tell yes. Now moving on, let's again check for a target, say example 11. Let's check it out. 4 plus 2, that is 6, that is not 11. 8 plus 4, nah. 8 plus 13, again not the target. So we'll tell no. Now comes the second variety of problem in which we have to give the indices of the two found integers which adds up to the target, that is a plus b is equal to t. We need to give indices of these two, that is in the problem statement. So basically the indices will be 0, 1, 2, 3 as I have discussed in my last video in which I said about array. If you haven't seen that, check out the link in the I button. So basically now we will have 1 and 2 adding up to the target. So our answer will be an array of 1 or 2. So this will be the variety of our problem. Now let's quickly dive into the brute force approach, from where we'll go to some intermediate approach and lastly we'll go to the efficient one. So here is our brute force approach, in which what we'll do for every integer we'll check all the other remaining integers in array and add them so that we get to know whether the target exists or not. So for example, we'll go with 1, we'll add 4. Do we get 10? No, it is 5, so not. Then we'll again add 1 plus 8. Do we get 10? No, then again not. Then again 1 plus 3, then 1 plus 2. After that we'll come back with the element on first index, that is 4. We'll add 4 plus 1, that is 5. Target doesn't exist. We'll go in the similar way, adding each and every other integers whether the target exists or not. So it will be like for I is equal to 0, I less than n, I plus plus, and here we'll go with for j is equal to 0, j less than n, j plus plus, and we will have, for say example, if I is equal to j, do nothing or instead continue, and if I plus j is equal to t, there will be two equal to's, then we'll return I plus j or we'll return yes. Instead we'll return no. So this will be our whole problem in brute force approach. What will be the time complexity? So no matter what, we have two for loops. each going from 0 to n. So our time complexity will be n square, that will be capital O of n square. Now there is one little improvement we can do in our brute force is that, so for example, if we are checking 1, we are adding all other digits to it. Now when coming back to 4 and checking all other digits, we are again checking for 1, right? So there is no point in again doing the calculation which we have already done. Like for example, in 1 we have already checked that 1 plus 4 is equal to 5, that is not our output. Then why again to go and check 4 plus 1 is equal to 5 again? I mean, that is kind of a redundancy, again doing the calculation which we have done. So we can minimize that. So instead of doing j is equal to 0, we can directly write j is equal to I plus 1, which will ensure that j will always be starting next to the I. So we no longer need this check because never I and j will be equal. So this is our problem statement in which we have an array and a target, and we need to output the array which will contain the starting index and the ending index. That means start plus end should always equal to target. So I have replicated the same stuff here. We have made an integer, we have given a target. Now we have a method that is toSum, and we are supplying them array as well as target, and later we are printing out what is our result. So let's quickly see what is our method. This is the brute force approach that I have already explained. This is kind of some beginner level code which we have again beautified it with like removing brackets and all, which are all not required. And lastly, we have the solution in which we have ignored the redundancy. Like rather than starting from I is equal to 0 and j is equal to 0, whereas we are starting from j is equal to I plus 1. Always remember here it will go till array.length minus 1, because if you give array.length here as well, it will give you array out of bounds exception. So let's run one of them and see whether or not we are getting a correct answer. So our result is 9, which we should definitely get, and it is 0, 4, that is 3 plus 6, that is 9. So this is done. I mean, I am not writing this in Leetcode because anyways it is going to give us TLE, that is time limit exceeded exception. So this will again be a big O of n square, but little less runs in comparison to our extreme brute force approach. So we are done with our brute force approach. Now let's move towards our approach that will be better, either big O of n or big O of n log n. In brute force approach, we had big O of n square. Let's minimize that and let's traverse the array only one time, that is linear time complexity. So basically what spell we will be using in this step is called as hashing. So let's think of the approach in this way, that for example, if we are looking at 3 and our target is 10. So we need something that should be added to our, for say example, element A, that makes it equal to target. So this is the simple thought process. If it is 3, obviously we need an element that is 7 that should be present in the array, that will sum both of them to become the target. So this is our thought process which will be gonna follow. For doing dry run of this concept, let's simulate a hash map here. Hash map is a data structure that stores keys and value pairs. So for every element, say for example 3 and the target that is 10, we will find whether the hash map previously has the element stored, that is B element, whatever 3 requires to be added into to make target, is already present in hash map or not. If it is not present, we will just store the element 3 with his index that is 0 in the hash map. So 3 will be the key and 0 will be the value. So in this way we will do the dry run. So first of all we get the index 3 and the target is 10. So 10 minus 3 is 7. Do we have a 7 before in the array, that is on left side of this element? So left side of this element has nothing. So we will store 3, 0 in the hash map. Now we'll move on to the next target, that is 4. So for 4 we require a 6 to make it equal to target, that is 10. So do we have a 6 in our hash map? So no, we don't have a 6 in the hash map. So we'll store 4 with 1, that is its index, in the hash map. Now going on to 8. Do we have a 2 that is required to be added to 8 to make 10 in the array previously? or in the hash map? No, we don't have. So again we will store 8 with index as 2 in the hash map. Going on, we'll go with 9. We'll check whether do we have a 1 in the hash map previously. So no, we don't have a 1. So we'll store 9 with index 3 in the hash map. Now the last element, that is 2, we will check do we have a 8 in the hash map which sums 2 to 10. So yeah, we have 8 in our hash map already present. So what we'll do now is we will return yes because we got 8. So for the problem in which we need to specify I as well as j, we are already at 2, that is at I index 4. And now we just need to do a hashmap.get key. Key is again 8 and we'll get the value here, that is 2. So we can easily determine I as well as j in the array. So now for our hashing approach, let's quickly initialize a hash map with both keys and value as integer. We'll name it as map is equal to new hash map. We don't want a capacity. Now we'll write our for loop with int I is equal to 0, I less than a dot length, lastly I plus plus. So in this for loop we'll check whether or not map already contains a key, that is target minus a of I, which we have already discussed. So we will do if map dot contains key, that is target minus a of I. So if this condition is met, we'll return an array that will be 2 indexes, start and end. Start being the element which we are trying to find out in the map and end being the index that we are already at. So let's do that. Return new int of, will get map dot get and our key, that is target minus a of I, that is the same stuff. This one will be our first, that is start index, and our end index will be no doubt I. So this is our return statement. But what if this condition is not met? I mean, what if you already don't have the key in map? So in this case we'll just add an element to map, that will be map dot put the element, that is a of I, as well as its index, that is I. So this was the best case scenario. What if we don't have the target itself in the array? So in that case we'll return an array filled with negative ones. So we can do like this, or we can even use arrays.fill. So let's run this, whether this works or not. So we get our indexes as 1 and 2. Let's see, 1 is 4 and 2 is 5. So 5 plus 4 is 9. Now let's run our code in Leetcode and see what are the time complexities and runtime we are getting. We will just modify our code little bit according to what we have coded, and I guess we are good to go. And yeah, this is accepted. Let's see what are the time complexities and run times involved. So this is our output. Our code is still 2 ms and it beats 82% of the users with Java. So let's quickly talk about the time complexities and space complexities involved in it. So basically the time complexity in this solution will be definitely O of n log n. Why O of n log n? Because we are traversing the whole array, as well as we are thinking about the time required in storage as well as finding operation of hash map. So if we consider something like an unordered hash map, it will be O of n in best case scenario, but in worst case it can go till O of n square, because finding operation in unordered map is sometimes really costly. Now talking about space complexity, so basically we are storing each and every element in the worst case. So we'll be storing 3, 4, 8, 9. I mean, definitely this was the worst case which we went through, because the last element summed up to the target. So in the worst case scenario, we'll be definitely having a O of n. Why is it? Because we are storing all the elements and the length of array is n. So I hope you get it. Even not, just comment in the comment section. I'll make a video specially on how to understand time complexities and space complexities. Let's now quickly move to the more optimal, a better efficient solution. Your interviewer might ask you that O of n log n is nice, but you are taking a space of big O of n, which is not acceptable. I want to do this stuff in big O of 1. I mean, you may or may not improve this, but you can definitely improve the space complexity. So your next approach that will take you to the optimal, or let's call it efficient solution, will be something that involves a two-pointer. It's a greedy concept in which we need to ensure that the array is sorted. So now let's quickly start the dry run of two-pointer approach. If you want a separate video on two-pointer approach, you can comment it out. I'll make a separate video for that. So in two-pointer approach, we will have two different pointers, that is start and end. Start being on the 0th index and end being on the nth index. So in this case, we'll have three different approaches. Case 1 will be our S plus E is equal to our target. Case 2 will be our S plus E is greater than our target. And case 3 will be our start pointer and end pointer being less than our target. So now let's do the dry run. In our first run, we have S as 1 and E as 18, which sums to 19, which is definitely greater than our target, that is 12. So this goes to the second case in which our sum is greater than our target. Always remember this word, that is sorted, which is our array right now. So in sorted array, we have the highest element on the nth position, that is it goes on ascending order, lowest, little more, highest. So this is our highest element. Now to reduce the sum, we cannot go left of the first index because it is nothing there, it is already on 0th index. What we can do is that we can go on left of our rightmost number, that will reduce the sum. So in this case, we have left of our, let's change the color of pen, we'll do left of our rightmost number and we will get our new number now. So what will happen is that rather than again summing with 18, we'll go to 13, we'll make it as our end pointer and we'll do the sum. So our second run will be 1 plus 13, that is 14, which is again greater than 12. So we'll again shift our end pointer to 1 index to get our next sum. So our next run will get 1 plus 8 equals to 9, which is greater than 12. So we go to case 3, in which our start plus end pointers are less than our target. So our target is greater now. So what we'll do, rather than shifting our rightmost number to 1 index left, which decreases the sum, we'll shift our leftmost number to 1 digit to increase the sum. So now our start pointer won't be 1 anymore, we'll make it 4 now. We just shifted 1 digit to the right. So in this one, we will have leftmost pointer shifted to 1 index right. So in our fourth run, what we get, 4 plus 8, which is equal to 12, and we get our case 1, that is we get our answer. So you can now give out the result as yes, or in the other case if you want I and j, so our I is S and our j is E. So this is the answer you get. And this is the most efficient or optimal solution of 2sum. Now let's quickly go to our IntelliJ and code the solutions out. So let's code out the solution using two-pointer approach. Always remember, it is beneficial only when array is sorted. If it is not, let's write a simple method that will sort out the array, that is arrays.sort. But again, if array sorting is not allowed in the context, which we'll soon be going to see, you cannot be able to use this method because sorting itself is not allowed. Now, for those cases, we'll just remove it out for now. We will assume that array is already sorted, and we will create two pointers, that is start, which will be at index 0, and end pointer, which will be at array a.length minus 1, that is at last index. Now we will create a variable sum that will sum whatever is present on start index as well as end index. As already discussed, we will have only 3 cases. We will note them down one by one. If sum equals target, our second case will be when sum is greater than target. So when sum is greater than target, we'll move our end index to one place left. So it will be end minus minus. And lastly, our case will be when our sum is less than target, we'll move our left index one place higher. So it will be start plus plus. And lastly, we'll have else condition. If the element is not present, we'll return something like array filled with negative ones. So yeah, this is again 3 and 6. So this is the 0th index and this is the 4th index. So talking about the time complexities involved in this particular solution, so it is clearly big O of n because we are traversing the whole array, one from left side and then from right side. So at worst case, it will be one complete traversal. But if array sorting is involved, so then the time complexity will be big O of n plus big O of n log n, which will be written as big O of n log n. So in worst case, when we need to sort out the array, it will be big O of n log n. Talking about the space complexity, we are not using any space, so clearly it will be big O of 1, that is a constant time complexity. So let's quickly paste our code on Leetcode and let's see what our time complexity is involved. I personally don't think it will work because you can see this case here, the array is not sorted, it's 3 2 4, and even if we sort the array, the new array will be 2 3 4 and the solution should be 0 comma 2, but the expected solution is 1 comma 2, that is, it is expecting the solution for this array itself. So I think this test case will possibly fall. Yeah, as I said, I mean, we cannot check it out here, but yeah, this is one of the efficient solutions where the sorting of array is possible. So this was all about the two-sum problem in which we learned the very brute force approach. Then we went to intermediate and lastly we learned the efficient solution. In the next video, we will be learning how we can remove duplicates from an array. So kindly be with me. If you haven't already subscribed to Rejoin Tech, do it as fast as you can because we'll be learning a lot of stuffs. So take care guys. See ya.